while we were in the unit discussing normal probabilities and the central limit theorem, I actually wrote a homework problem that actually roughly walked us through the idea of hypothesis testing without even knowing what it really is yet. So I'd like to revisit that problem so I can put it in a little bit more context. So that problem was about this study which was looking at actually extremely high levels of vitamins in vitamin supplements given to pregnant women, and they stopped the study partway through due to this issue where they've got these 25 pregnant women that were put on a diet, and the length of pregnancy for these 25 women was 270 days, which maybe doesn't seem that far off from the 281 days that are typical, right? That 281 days is the mean for the entire population. But these 7 women out of those 25 had premature babies, which is certainly more than the 5% that we would assume would have premature babies. Remember, premature birth is defined to be the 5th percentile, which means we would expect 5% of pregnancies to be born at this premature age. Okay, so we want to find out if 270 days is an unusually short length of pregnancy for this group of 25 women. The question is, what probability do we need to find? Well, let's think about this for a second. So we might immediately jump to the probability of getting an average of 270 days for the length of pregnancy here. But what we're actually checking is 270 days an unusually short length of pregnancy? And we can measure how unusual something is by checking its probability. If the probability of something happening is like 90%, that's not unusual at all. It's very common. If the probability is less than 1%, I would say it's quite rare. That's unusual. So what we're going to look for here is see how small our probability is, because that's going to measure how unusual it is. And here's the basic logic behind it. If 270 days were unusually low, then so is 269 days. And 268 and 267 and every number lower than that. So if I want to check if 270 days is an unusually short length of pregnancy, I don't want to find the probability that my mean is 270. I want to find the probability that I get an average length of pregnancy that's no more than 270 days, right? That it's 270 or less. That's how I check if something's unusually low. And then I'll just look at this probability and see if it, to me, feels like a very unlikely thing. If so, then we would say it's quite unusual. So this is what I'm going to look for. So remember our length of pregnancy, I'll just call it L, I guess, for the length of pregnancy, was normally distributed with a mean of 281 days and a standard deviation of 13 days. And we know from that central limit theorem section then that the average length of pregnancy, I changed from X to L partway through here. Let me just rewind. There we go. That this average length of pregnancy will still be normally distributed, right? So usually here, note we only had a sample size of 25, and at least for this course, I said, look, we're going to use this rule of thumb where I need a sample size of at least 30, actually. 25's not quite there. I need a sample size of at least 30 to invoke this central limit theorem, which allows me to find this kind of probability. Or, if my variable already was normally distributed, I can apply the central limit theorem anytime. Well, here, since the length of pregnancy was already normally distributed, I'm allowed to do this even though I've only got a sample size of 25. So we know from that section that nothing happens to the mean. It's still this. But my standard deviation needs to be adjusted. So this new standard deviation that I'm going to have is going to be my original divided by the square root of my sample size, right? None of this is new. This is stuff we've already known how to do. So that's 13 divided by the square root of 25. 13 divided by 5 gets me 2.6. All right. So this is just honestly review at this point. But let me go ahead and just quickly flip over to Minitab to actually, to get, there we go, to get that. So if I go to Graph and Probability Distribution Plot and View Probability, I have a normal distribution with a mean of 281 days, a standard deviation of 2.6, and I want to find the probability of being less than 270. And if I look at this here, I see that I've essentially got 0 out to 4 decimal places. So 0.00001. So this would happen about 1 every 100,000 times. Basically a probability of 0, right? This is incredibly unusual then. I can at least say that. If it happens 1 out of 100,000 times, that's incredibly unusual. Definitely we can make the claim that it's an unusually low length of pregnancy for a group of 25 women. So we actually made an assumption as we went through this. And here's where the actual hypothesis testing part of this comes in. So far, everything we've done was just something we did in that normal probability section. We actually made an assumption here implicitly without actually stating it. So let's look at this. So the length of pregnancy for women in the United States has an average of 281 days with a standard deviation of 13. Now, as I went through my calculations here, I continued to use this. But is this mean for women in general exactly the same as the mean for women that were put on this diet, of women that have this mega dose of, I think it was vitamin D, I can't remember, this mega dose of vitamins? Is that length of pregnancy exactly the same? Because now I'm looking at a very strict subgroup, and actually I don't even know if subgroup is really the right word, because it's actually like a new group, a separate population from this. Using this was making an implicit assumption here that the diet had no effect on the mean length of pregnancy, and therefore I can just use this same mean for the general population with my group. All right, because I used this, that was for the general population, for my group that actually was taking these vitamins. Again, by using that number, I'm making the assumption then that the mean has not changed. In other words, that diet did not change the average length of pregnancy. So that was an assumption I made. And then as I looked at the data, which is the only, right, this assumption is just an assumption, right? It's not based off of anything. It was just an assumption we made to do the homework problem. But as I looked at the actual data, right, the actual 25 observations we have, which is the only objective understanding of reality that we have, we must assume our data is at least true, right, that we've correctly observed things. As long as I have that, under that assumption, what I saw, which did happen, was insanely unlikely to happen. So unlikely to happen that it calls into question whether it even, like, that like something's not right here, like something doesn't make sense, right? It's like when I flip a coin 50 times and I get heads every single time, right? Now I'm calling into question whether that coin is actually like a legitimate coin or whether it's like got heads on both sides or something, right? Like now I'm calling into question something. A basic assumption like here is gone wrong. And that's the basic idea behind hypothesis testing, is that we make some assumption. We check to see how unusual my observations are under that assumption. And when they're insanely unusual, like that seems like incredibly rare for that to happen, I need to ditch that assumption, because this assumption that the mean hasn't changed, it's just an assumption. It's just some claim I'm looking at. It's the data that I am assuming is actually true. And it's a little bit like when we go into the court system and we assume someone is innocent always, right? We always assume that. That's just what we do in a court. It's the evidence that we assume is true, and we're trying to see if there's enough evidence to get over that assumption of innocence. It's a little bit like that here, where I've got some assumption that the mean hasn't changed, and with the probability so insanely low, right? Because this was basically 0. With an assumption with that assumption, having a probability of observing what I actually saw of basically 0 means something went wrong here, and what went wrong was that the mean is probably not 281 days anymore. It probably did reduce that length of pregnancy. That's the far more likely outcome than this 1 in 100,000 chance of this thing happening. So that's really what's going on here. I'll try to adapt this to the hypothesis testing framework in the next video.